So a lot of this observed variety was explained through so-called unification models, which a kind of cartoon version is given here, or in more details shown here. So the idea is that there is a black hole with a hot accretion disk in the middle, a lot of ionizing radiation, clouds of gas are highly ionized by that radiation. Because they're so close to the black hole, they move at high speeds. So that explains presence of strong broad emission lines. A little further out, gas is still illuminated by this UV radiation, so you see strong narrow emission, but they're moving at normal speeds for stars and galaxies, like hundreds of kilometers per second. So if you're looking from an oblique angle, you see that whole thing. You see continuum from the accretion disk. You see broad emission lines from clouds near the black hole. You see narrow emission line clouds from clouds a little further out. But if you're looking from the side, the continuum source and the broad emission line region are obscured. You only see the narrow emission line clouds. And those are a type 2 AGN. And if you're lucky and look right down the jet, then you have all these extra phenomena due to the Doppler boosting, and those are the BLX. So this picture can pretty much explain all of the observed phenomenology with one distinction, which is doesn't necessarily tell you why some are radio loud and some are radio quiet. So unification of active galactic nuclei basically says, well, it's all one kind of thing. They differ in the accretion rate, which maps into luminosity, because just like with accreting binary stars. But they come either in as obscured or unobscured version, or blazars are extreme version of unobscured version. And that pretty much can explain just about everything that we've seen about. But for that difference of radio loud versus radio quiet. So the possible, not entirely proven, but very likely, explanation is that they're due to the difference in the spin of the black hole. Black hole can be stationary, Schwarzschild black hole, or could be spinning, Kerr black hole. Black hole can only have three quantities about it: mass, always, angular momentum, and electric charge. And because their charges are so well mixed, they never have electric charge to speak of. And so the difference here is that in the spinning black holes, if you had magnetic field present and then bound together, that can produce jets to accelerate things. And so that energy then gets extracted from black hole, from the kinetic energy of black hole, just like with pulsars, the energy was extracted from kinetic energy of rotation. And in radio quiet case, black holes have low or no spin, and most of the emission is really produced just by accretion. So how that can be, right? So just like it's hard to spin up neutron stars, in order to produce a millisecond pulsar, it's even harder to spin up black holes then. And the best way is to do mergers. So you'd expect then that however you make initial supermassive black holes, they'll probably be radio quiet. Then as merging of galaxies proceeds, occasionally you have major merger of two that would create a product black hole with a very high spin. Those events we should be able to see in gravitational waves someday. But there is a hint that indeed the onset of radio loud quasars lags behind the offset of radio quiet ones in the early universe. So that fits nice in this picture. So therefore, a lot of the observed classification is really apparent. It's just due to the angle from which you're looking at it. And a priori, you didn't know that. So a simple example would be, say, if you're an extraterrestrial coming to planet Earth, flying in your UFO over Los Angeles, you'll conclude that cars are the inhabitants of planet Earth, and you classify them by color, right? There are silver ones and white ones and red ones. Red ones are a little faster than anybody else. But they all have same engine inside, which you don't see directly. So a more physical classification would then be something like this. There are two relevant properties of the black hole itself, mass and the angular momentum. And what produces energy is accretion, So there has to be mass accretion rate. So these are three minimum quantities needed in order to account for these things. And in fact, from what we can tell, there is more or less a relationship that follows exactly like this. And then on top of that, you have obscuration, which is superficial, but just then emphasizes or de-emphasizes some of the observed quantities.